Alright, today we're going to be looking at exponential models. I've gone through the practice and looked at the problem. We won't actually be hitting all of these objectives, but I will just go through the learn and show you the most important parts. We will be using exponential functions to solve applications. That's the biggest part. We're going to solve some involving compound interest, and we're going to use them to solve exponential decay growth functions. Those are going to be the most common type of problem we're going to see in this section. So we talked a little bit about growth and what the graphs look like in the previous section, but here is a model of growth. You can see it's going through that point 0, 1, and then here's some examples. So just plugging in some points for you. And then here's a model of decay, what decay looks like. However, this isn't, it normally starts on that left side, but for positive scenarios, this is more fitting of a real world scenario. But that's just a model of decay, and it gives you a little information about how it's used. It's very much applicable it's very much applicable as far as wildlife. If you have some animals in the wild and then you introduce a predator, and then they start dropping off, so this model does fit what really goes on in the wild. This example 2 is very good. It's similar to number 3 that you will see in the homework. Goes through and explains how to do it, and I will work it exactly like this. You will need a calculator in this section. Graphing calculator will be best, so you can do it the same way that I do it. But even if you don't have a graphing calculator, you can still do a lot of this with a basic calculator. Compound interest. So this kind of starts talking about compound interest. We're going to be using this quite a bit. This is going through like the background of how the formula was arrived at. Here's the most important part. Compound interest formula. A is the final amount. P is the investment or the principal amount. R is the interest rate. N is the number of times interest is compounded. And then T is the number of years. So T is in years. So that's what all of these things are. P dollars is what you put in there. N, how many times you compound a year. R is the interest rate. T is the number of years. And this over here represents the final amount. This is the mathematician that came up with this. Here's some examples of that being used. We will be using technology to solve it. You can't really do this by hand. You can't do that by hand. You can probably estimate. Here's another example, which I'm going to skip over. I'll do all the examples in all. But this is probably the last bit most important piece. This is helping you to identify N in that compound interest formula. So if they say annually, it tells you one time a year. So that's what your N is. Your formula is simplified. You don't have to divide. If it says biannually, semi-annually, N is equal to 2. Quarterly, N is equal to 4. Monthly, N is equal to 12. Weekly, daily, and then hourly. So you have several different ways that we can compound interest in a year. So these are the ones that will help you. This is the values that you will use. And then other than that, there are some other good information here. They talk about the number E. That's just part of the exponential formula. This is continuous compound. I don't remember seeing the continuous compound formula, but if we do, then this is a formula that we'll use. And I just remember in school they calling it PERT, kind of like there was a shampoo called PERT, commercial a long time ago, but TERT helped me remember that formula. And I think that will be all that we will see in our section. So they do talk about exponential regression. We have scatter plot and numbers to do that, but if that pops up when we need it, I will show you how to do that at the time. But as far as what we need, the most important things, let me just go back, are the compound interest formulas. Here on, I guess, page 6 of the 17, and then you skip 3 times over, and then you get the compound times per year. So this helps you figure out N. This is what we need. We're going to be using that quite a bit in the calculator. So I guess with that, we'll jump over to Hawk and actually start doing them.